In this problem, we'll talk about how to find the number of charge carriers that passes through a device in a certain time. So what information we have given here is the current. So let's say we have a device. Let's say I'm calling this as a device here. So this is a device here. Let me draw a better picture. So this is a device. And a current, let's say call the 10 ampere current is passing through this device. 10 ampere current. So 10 ampere current is passing through this one. So what we need to find out is how many charge carrier passes through this device in 5 seconds. Okay, how do we do that? How do we find it out? Let's do this one. So information we have is the current. So the current is given, which is 10 ampere current, and the time is given, that is the 5 seconds. And here we assume, or it is said that the number of electrons. So we know the magnitude of the charge of the electron, that is E is 1.6 times 10 to the minus 19 coulomb. This is the magnitude of the charge of the electron. Here I'm just talking about the magnitude, not the sign. An electron. We know that I, the way the current is defined is the delta Q, the charge that passes through in a certain time, the delta T. So from this equation, the delta Q, the charge, is given by I times the delta T. So I is given with, that I is 10 ampere. The time is given, where the time is here 5 seconds. So let's multiply this together. So this is in amp and this is in seconds, so that's the proper unit. So we have 50 coulomb charge. Okay, that's a 50 coulomb charge. So if this much charge is, then how many electrons will constitute this amount of charge? Okay, so that you know that the charge happened because of the electrons or the charge carrier. In this case, the charge carriers are the electrons. So how many electrons need to pass so that this one will have a total charge of 50 coulomb. So from quantization principle, quantization of charge, what does the quantization of charge tell you? It tells you the charge is an integral multiple of the number of charge carriers, or the electrons in this case, and we need to find out the number of charge carriers or the number of electrons. So the N will be simply equal to delta Q over E. And if I have to tell you a little bit of background about this quantization principle or quantization of charge, the charge is always an integral multiple of charge of the electrons. It cannot be a fraction of. When I say the numbers, like a particle or an object can have either 20 electrons or 25,000 electrons, it cannot be 25.2 electrons. It has to only be integral multiples. Okay, there cannot be a half electron or a fraction of electron. So this rules holds. So delta Q over NE, because the charge cannot be a fraction of an electron. It has to be integral multiple of a charge of an electron. So now let's plug in all the values now. The N, the delta Q we just calculated is 50 coulomb, and E is 1.6 times 10 to the minus 19. So this unit is in coulomb, this is in coulomb. So now let's do this math. 50 divided by 1.6 exponential minus 19, the number here we got is 3.125 times 10 to the 20. I just mentioned that it cannot be in the fraction. So the answer I can write down, I mean this is a correct answer. So this is 10 to the 20. So if I have to write down to this one decimal places, simply I'll just write down this way, 10 to the minus 20 electrons. Okay, so this many electrons passes through this circuit or through the device in 5 seconds. So this is it. Again, if you have any questions, any confusion, let me know, and do not forget to like, share and subscribe the channel. Thank you very much.